Today we will be simplifying complex fractions. So first we'll start off with the definition. The definition of a complex fraction is a rational expression that has at least one fraction in its numerator or denominator or both. And we're going to look at a simple numeric example first, and then we'll do something a little more complex. I'm going to look for that giant thick fraction bar. Notice we see it here. And we're going to write it as a division problem, just like we did earlier. So 2/3 plus 1/4 in parentheses, because I have to do that first, divided by 1/12. Okay, now remember, in order to complete this setup, it's like with order of operations. So you have to do the parentheses first, so we're going to add 2/3 with 1/4. Now notice that the lowest common denominator here, LCD, if I could do the acronym correctly, is 12. So what we'll end up doing is we'll be multiplying the 2/3 by 4, top and bottom, and the 1/4 by 3. Okay, so notice we'll have 8/12 plus 3/12 divided by 1/12. Okay, now I'm going to write that as one fraction, that is 11/12 divided by 1/12. And remember what we did, 11/12 remains untouched, the division becomes multiplication, and we invert the second fraction. And notice the 12s cancel, and our answer is 11, and that's it. Let's try another one. Okay, so just like we did with the previous simple example, we're going to identify that scary fraction bar. Notice it is right here. So we'll have our top x plus 2 over 5 divided by our what's below that green line, 5 over x minus 6. And I don't need any parentheses because neither general numerator or denominator has multiple fractions. Okay, so now we're just going to x plus 2 over 5 remains the same. We change division to multiplication, and remember you multiply by the multiplicative inverse. So the x minus 6 becomes on top, 5 becomes on bottom. Now notice in this one, nothing really does cancel out, so we just multiply just like we do with normal fractions straight across. So our numerator is x plus 2 times x minus 6. Now if you wanted to distribute that, you can, but you don't need to. And then all that's left to do is to state our restrictions. So notice places where we had an x in the denominator, and the only place was here where the x minus 6 is. So therefore, x cannot be 6. And that's it. So let's look at some examples. We're going to simplify and then state any restrictions on the variables. So let's look at letter A. So remember, we're going to identify the fraction bar, and it is right here. So we'll start off by saying 5 over 1, right? Because we're dividing fractions, I want to keep things in fraction form to alleviate any confusion. And because we have two fractions below that big fraction bar, I'm going to need parentheses over the 10 over x minus 3 and the 15 over x. Okay, so the lowest common denominator of this group is x and x minus 3. Okay, so we still have our 5 over 1 divided by. Now, that x minus 3 become x times x minus 3. You have to multiply top and bottom by x. And for the 15 over x, you have to multiply top and bottom by x minus 3. Okay, now we're ready to distribute and combine like terms or write as one fraction within those parentheses. So 5 over 1. Ugh. Let's make that a good looking 5. There we go. Divided by, let's see, we'll have 10x plus 15x minus 45 over x times x minus 3. Okay, and if you want to do the multiplicative inverse of the divisor, you can. X times x minus 3 is on top, and the simplification of this guy is the denominator. So that would be 25x minus 45. Okay, and nothing's going to cancel out, but we can reduce, because 25x minus 45, there is a GCF of 5. And look, these 5s now cancel. Okay, so now we're ready for our final answer. We'll have x times x minus 3 over 5x minus 9. Now, based off of our answer alone, we know x cannot be 9 over 5 because I'm going to set that 5x minus 9 equal to 0. Let's look up in previous. Notice that we have denominators here. Okay, so we also have to include 0 and 3 in our lowest common denominator. And there's our answer. Okay, so remember, the first thing we'll do is we'll identify that big fraction bar. And notice we need parentheses both the top and the bottom. So 2 over x minus 5 over x minus 4 divided by 5 over 3 minus x minus 4 over 6x. Okay, now our lowest common denominator for this first group is x and x minus 4. For the back group, the LCD is 6x. Okay, so that 2 over x, to turn that to x times x minus 4, you need to multiply top and bottom by x minus 4. For that 5 over x minus 4, you'll need to multiply top and bottom by x. Okay, now for the other group, the 5/3, you want to turn that denominator into a 6x. You'll multiply top and bottom by 2x. And for the x minus 4 over 6x, that is going to remain unchanged. Okay, so next step. I'm going to write everything in the big parentheses as one fraction and distribute here at the same time. Remember, this is a negative 5x. So 2x minus 8 minus 5x over x times x minus 4 divided by, same thing with the back end. We'll have 10x, and this is a negative, so that negative has to go to the x and to the negative 4. So negative x plus 4 over 6x. And now we have a division problem. So when we combine like terms in the numerator, we do have negative 3x minus 8 over x times x minus 4 times, remember 6x is now your numerator, and the denominator becomes 9x plus 4. And notice what's going to drop? Just the x. That's crazy. So our final answer, will have 6 times negative 3x minus 8 over x minus 4 times 9x plus 4. And x cannot be. We're going to say 0, 4, negative 4 ninths. Let's go back and highlight anywhere else. So we had this one, this one, this one. We already got 0. We got 4 and 0. I think we are good. And so therefore, this is our answer. I want you to take a few minutes and try both example U-tries. Okay, so hopefully for A, you did get x squared y over y plus x, where x cannot be 0 or negative y, and y cannot be 0. And for letter B, hopefully you found x minus 1 quantity squared over 2x, where x cannot be 0, negative 2, negative 1, and 1. That domain was a little trickier, because you have to take into account, you have your 0, you have the x plus 2, you have the x plus 1, and then this x minus 1. All those have to be in your restricted variables. And you're ready for practice. The end.